Hello everyone. Today we're going to solve the fifth Leetcode problem called longest palindromic substring. Basically the idea of this problem is you're given a string and you're trying to find any palindromes in it. And you're trying to find the longest palindrome that you can find. If you don't know what a palindrome is, it's any string that is the same when it's reversed. So for example, I think race car is a palindrome. And they also give these examples here. If your input BA, BAD, the longest palindrome is BAB or ABA because these strings can be reversed and they'll still be the exact same string. So that's what we're going to do. And I'm going to try to make this video without any editing. So I'm not going to cut out any long pauses. Hopefully there won't be any long pauses because editing takes forever, and we're going to try to just speak our thoughts the entire time. Also, I have looked at the solutions tab already, which is different than my previous videos. And there's apparently four different solutions, although one of them didn't work, which is weird that they included it in the solutions tab. They intentionally say it doesn't work. And two of the solutions stood out to me. One is a dynamic programming solution, which basically means you're trying just to reduce the amount of work that you do. One way to do that is like using a cache, sort of. So we're like storing values because we know that we're going to need them again. And another solution was something to do with how palindromes work, where they always expand from their center. There's only a certain amount of centers in a string, and you can do it in like a complexity of O of n squared. Also, the dynamic programming solution is O of n squared. And we're going to try the dynamic programming solution because it requires recursion, and I like recursion. And I had one other thing to say. The brute force solution, which would be try every index, try to find a palindrome. So like you have a nested for loop, basically. The outside loop is the start index, the inner loop is the end index. But then for every set of beginning and end indexes, you also have to see if it's a palindrome, which also requires looping through it. So it's actually O of n cubed, n to the third power. That's squared cubed. I'm pretty sure cubed is 3. You know what? If I'm wrong, I'm sorry. Cool. So let's jump into the quote-unquote dynamic programming solution. Basically, the approach is we're going to loop through the string a single time, and for every index, we're going to say this is a palindrome, and then we're going to pass it off to a function, and that function is going to try to expand the palindrome using recursion and also caching its previous results. So we're going to start at like index 0, and we're going to say B is a palindrome, try to expand it. And it's going to try to expand to the left and to the right. And if the character to the left and the character to the right are the same, then you have successfully expanded your palindrome, and then you recurse and try to expand again. Also, at every index, we're going to try to expand the set of characters at the current index and the one after, because some palindromes are even length and some palindromes are odd length. So you have to try with the single character palindrome and with the double character palindrome. And some of them are going to be immediately rejected, which is cool. But if we pass in 2 characters and they are the same, then we can try to expand the palindrome by again checking the character before and the character after. And if they're the same, we expand the palindrome, yada yada. And then for each function call, it's going to, return, I don't know what it's going to return. I guess the palindrome that it landed on. But if, for example, that we pass in 2 and it's not a palindrome, we can't return that. We'll have to return something else. I'm thinking maybe a little bit too far ahead. Maybe not. Let's do some planning. I want to have a single for loop, basically, that goes through all the indices and initializes, quote unquote, these palindromes. And it's going to push all the results onto an array. And in that array, we should have at the end a palindrome, and then we can find the longest one, which just requires one loop through it, checking all the lengths, and returning the biggest length. And we actually have to keep the palindrome because that's what we need to return from this problem. Yeah, I think that's fine. If we do send in an invalid palindrome, we'll just return back the empty string. I think that'll be just fine. So we could either start with writing the function that tries to expand a palindrome, or we can start with the for loop. I kind of want to start with a function. So we're going to call it ExpandPalindrome, and it's going to take a start index and an end index, and it's going to try to expand it. We're missing something here, which is an equal sign. Awesome. So the start index, these could be the same for a single character palindrome. And we also want to cache all of our results. We don't have to start with. We could maybe add that later to not distract ourselves too much. But we know that we can, and that's what's important. So let's see. So the first thing we actually want to check is our current start index through end index a palindrome. So to do that, we, I guess we don't want to check every time, do we? Because that's kind of a waste of effort. And now I'm thinking about this. So in one scenario, we assume it's a palindrome and return the empty string otherwise. I'm trying to think ahead here. If we check if start index and end index are the same character, if they're not, we return false. And we're already like recursed at this point. We might have a palindrome at a previous like recursion level, and we would still want to return that. Which I don't know if that's possible. We could try to like go one ahead. I don't really like that very much. I would rather just maybe not call ExpandPalindrome if we don't have to. I think every time we get into this, we should assume that we actually do have a palindrome. I kind of like that better. I think it's a little bit nicer. So let's do that. And then we'll just try to expand it. So basically, we'll say character before start index. What do we want to call that? Previous character or before? I'm going to go with before and after. So say before character is s of start index minus 1. And we do have to do some boundaries checking. We'll do that in a second. After character is s end index plus 1. And then if these are the same, we can continue expanding. If they're not the same, we simply return the slice of the string that we're at. So if before char equals after char, then we return expand palindrome start index minus 1 and index plus 1. And now I'm thinking we should have stored these values somewhere, but we're just going to do that, and it's going to be cool. And then if they're not the same, then we return s.slice start index and index. And that should cover basically every case. So if we can't expand, then we do it. And as soon as we can't expand, then we're returning the slice. And we know that at this point we have an index, or we have a palindrome. So I think just boundaries checking is left. So if start index is 0, then we also want to return the slice. So maybe we'll get our slice first. Sure. S.slice start index end index. This might be extra work. I don't know. Return slice if end index is, let's do triple equals here. If end index is not equal to the length, but is one less than the length, is equal to s dot length minus 1, then we can't grow that direction either. Then we need to return slice. I wish JavaScript had lazy evaluation. That would make this much easier. Same thing here. We, whoops, don't need to double return slice. So I think what we have here is the ability to expand our palindromes, which is really nice. So now we use our for loop, and we say let I equal 0, I less than s dot length, I plus plus, and then for each index we want to attempt 2 palindromes. We also need like an array here, so we'll call them our palindromes, and I want some space there. So we're going to try to push 2 different strings. One is a guaranteed palindrome, which is the single length, the single character string. It's always a palindrome. So we'll say push expand palindrome I, and we know, oh, hold on. So the way that we're doing this is already possibly wrong. We just need to handle perhaps start and index differently. So if we were starting at 0, 0, this slice would start at 0 and end at 0, and that would just be the empty string. We actually want it to take 1. So I think what we have to do is treat our end index as exclusive, or when we slice, do a +1 here, which actually, I think maybe that's better. Because if we treat it as exclusive, then we have to set our aftercare to be not index +1, which is not expand it. It's kind of confusing. I'm confusing myself, but I think this is fine. And then we're going to say that the start index and end index are treated inclusively, which means that it actually looks at that, includes the character. You know what I mean. And then the second one that we could push is the 2, the length of 2 palindrome. But we decided that we need to check whether or not it's a real palindrome before we call ExpandPalindrome. So we have to do that little bit of work here, which is if s of I equals s of I plus 1, then we also push ExpandPalindrome I plus 1. And in this scenario, so there's one thing I'm worried about here, which is at the end of the for loop, at the very end, we're going to give an index that is not possible, or we're going to try to reach an index that isn't possible, which actually, since this is JavaScript, I don't think it throws an error. I think it just throws undefined, which means that they'll never be equal, which means that this won't happen. So I think we're actually just fine. Yeah, I think that's okay. So now we're trying to, we should have a collection of palindromes at the end of this, at least of size 1. So what we want to do is find the longest one. And the way that we're going to do that, I believe, is with a reduce function. That'll be nice. So what we're going to do is return palindromes.reduce. And we're going to have our pal, and then let's see, let's call this one max, which stands for our maximum palindrome. And then we're going to call our palindrome p. So each palindrome is going to be passed in as p. And then basically we want to return whichever one's length is longer. And we can do that with a ternary, but it's not going to be pretty. Max.length greater than p.length. If so, return max, otherwise return p. And then we start with, we actually want to, what do we start with? It doesn't matter. I think we're not going to pass in a default value for our reduce, which means that our first max is going to be the first palindrome in our array, which is perfectly fine. So does this reduce work? If the max length string is longer than the current palindrome string, then return max. Yeah, I think that totally makes sense. And then, yeah, this came together really quickly. I was kind of scared. Let's give it a go and see what we messed up. I guess one part of editing means not editing these little bits out. Oh, snap. Oh, I'll be so excited if this just works. Oh no. Reduce of empty array with no official value. Okay. So we didn't handle that edge case, which is fine. Okay, nothing too nerve-wracking yet. We're just not handling the empty string. What's the best way to handle this? So what's happening is our palindrome. You know what? If we actually passed in the empty string into our reduce, then we would return the empty string because we would not, our palindrome's array is empty. So it would never call the reduce function, and it would just return our default value. And our default value of being empty will automatically be replaced by the first one length palindrome or any palindrome longer than that. But like our reduce still works totally fine. So I think that handles it. So that's cool. I'm nervous. Oh my goodness, we did it. Apparently not very quickly, but we did it, and that's super awesome. Apparently there was a faster solution. So like this one is supposed to be O of n squared, because for each index we, at maximum, we only have to do work for each other character in the string when we try to expand it. So like worst case scenario is the entire string is a palindrome, like it's all just the letter B or something, and we start at like, let's say like the middle index, and then we can expand successfully every single time. And so we had to do all the work, all the original work of setting up our palindromes and initializing them, and then we also had to do the work of expanding the palindrome, expanding the palindrome for every single character that's in the string, so we could expand it maximally, which is O of n squared, and it doesn't get any worse than that, because our piece of work that we do to check if it's a palindrome is this constant time comparison here, whereas if we did the brute force solution, we actually have to reverse and compare the characters, which takes more work. And apparently in the solutions tab, there's an O of n solution, which might be why we are only in like the half percentile or 50% speed as opposed to 100%, which means that a bunch of people would have actually done the best case solution. I don't know. Or perhaps, oh, I know what it is. We didn't cache anything. Look at that. I forgot. So our algorithm works, but we didn't do the thing that we're supposed to do, which is actually caching the solutions. Wait a second. No, we are totally caching the solutions because we're strictly expanding. No. I'm wrong. All that meant is Yeah, we are caching. There's no extra caching we could do here, I don't think. I don't know. I don't know why we're not the fastest. That's okay. We found a solution. It's a good solution. I might be wrong about it. Please tell me if I'm wrong. That this isn't Dovin's bird. And someone finds that out. Either way, thanks for watching. I'll put this code on GitHub. And let me know what I should do for my next videos. This is my 5th one. I was only planning on doing 5 to begin with. I was going to see if I wanted to do any more after that. I like doing them. I'm not sure if I'm like really providing that much value or if people are really enjoying watching me solve these problems. Is it the explanations that are good, or is it just seeing the solution? Because it's really hard to actually like speak my thoughts as I'm coming up with ideas, and I like worry that, you know, if I'm just sitting there like thinking, it's not really providing anything for the video, which is why I looked at the solutions tab this time ahead of time, because there was no point in me just sitting for like 5 minutes at the beginning of the video trying to figure out a solution and just like struggling over it. But also I wanted to like normalize that it's okay to make mistakes, and that's part of why I'm making these videos, is that like I've been working in software development for like 4 to 5 years, and I still make tons of mistakes. Like in the last video, I messed up the post increment operator, and that's fine. And you know, yeah, I don't know what to say about it. Hope you enjoyed it, and maybe I'll see you in the next one. I definitely want to keep making videos. I just might do something else other than Leetcode. Okay, bye.